Okay, shall I now? Second heading, v-tGraph. Okay, shall I? Everyone stop writing and just listen to me now. Shall I? Okay. v-tGraph. Generally, what M provides? M is nothing but your slope, and M is nothing but dy upon dt. Sorry, dx. Can I write like this? Or can I also write like this? M is nothing but who is on y-axis. This one will be on y-axis and time will be on x-axis. So can I write dv upon dt? And what is this dv upon dt? Can I say instantaneous acceleration? Can I say that? Same thing what we have learned just now, na? If theta is greater than 90 degree, m is negative. If theta is less than 90 degree, m is positive. Same thing we will be following here also. Okay, but this time theta will provide you the acceleration. That means slope will provide you what? Acceleration. In the last in xt graph, what we have learned that m is providing what? Instantaneous velocity. This time m will provide you instantaneous acceleration. That's it. Okay, so graph number 1. Consider this is your time, this is your velocity. If I draw like this, at v0, at t is equals to 0, what is the velocity of that body? v0. At t is equals to 1 second, what is the velocity? v0. At t is equals to 2 seconds, what is the velocity? v0. At t is equals to any time, what will be the velocity? v0. If velocity is not changing, then can I say acceleration is 0 here? So velocity is what? Constant. If velocity is constant, what is the sign of the velocity? Positive direction, negative direction. Body is moving in the positive axis. So can I say that velocity is positive? What about displacement? Obviously in the same direction. So displacement is also positive. S is also positive. What about acceleration? 0. Yes, very good. Acceleration is 0. Same thing, but in terms of Vt. What we have learned just now, na? Xt. Now this time is Vt. I got my point. In Xt, if I draw like this, if this is your x, this is your time. What is the velocity of the body? 0. Yes, very good. Right on. Okay, shall I now? Second one. Here is v, this is your time and origin. Okay, now listen to me. Can I say that at t is equals to 0, object is at having 0 velocity? Now, no position beta. You should not say position is 0. At t is equals to 0, velocity is 0. Maybe it is at 10 meter, maybe it is at 20 meter from the origin. Maybe the xt will be having a different position. Okay, so don't tell me the position is 0. Okay, at t is equals to 0, velocity is 0. Okay, got my point. Okay, now let me check the slopes first. Can I say this is your theta 1? Similarly, can I say this is your theta 2? Similarly, at this point, can I say this is your theta 3? Yes or no? Can I also say that theta 1 is equals to theta 2 is equals to theta 3? Yes or no? Can I also say that tan of theta 1, which is equals to tan of theta 2, which is also equal to tan of theta 3? Can I write like this? Okay. What this m provides you now? Velocity or acceleration? Acceleration. Very good. So can I say that if theta is less than 90 or greater than 90? Less than 90. If theta is less than 90, then can I say m is positive? If m is positive, can I say acceleration is also positive? M is providing acceleration in v-tGraph. So if m is positive, acceleration is also positive. Now, theta 1, theta 2, theta 3, all are equal. What this m is providing you? Acceleration. Then can I say that in this one, acceleration at 1 is equals to acceleration at 2 and acceleration at 3. All are equal. Over here, what is the acceleration? A1, at here A2 and here let's say A3. So can I say that A1 is equals to A2 is equals to A3, all are equal? Let's say A, and can I say that this A is nothing but constant? A is what? Constant. If acceleration is positive, if acceleration is what? Positive, and acceleration is constant, then velocity is increasing or decreasing? Yes, absolutely. Velocity is what? Increasing here. Acha, velocity is increasing with uniform or non-uniform? That means variable velocities or non-uniform uniform velocities. For example, if the acceleration is 2 meters per second, that means in every second velocity is increasing by 2 from its origin where the body is going. Are yes or no? Okay. What will be the velocity now? Positive, negative? Positive. Yes, very good. So velocity is what? Positive. Can I say that displacement is also positive? Yes, we can say displacement is also positive. So displacement is positive, velocity is increasing, acceleration is constant, acceleration is positive. Why? Because theta is less than 90, that's the reason slope is positive. Anything else we can comment here? We can say like this also. Body's motion is in this direction, velocity is in this direction, acceleration is also in this direction. Acceleration is constant and velocity is increasing. Okay, right on. Okay, shall I now? Let's move to the third one. Consider this time the graph is represented like this. This is your time, this is your velocity. At t is equals to 0, it is having some velocity v0. Okay. Before commenting anything on this graph, let us check first slope. Can I say this is your theta 1? Okay. Can I say this is your theta 2? And can I say this is your theta 3? All are equal? Yes. So can I say that theta 1 is equals to theta 2 is equals to theta 3? Can I also say that tan of theta 1 is equals to tan of theta 2 is equals to tan of theta 3? Okay. Now, checking what? Slope. Is it positive or negative? Theta is greater than 90, less than 90? Greater than 90. So theta is greater than 90. Then can I say that m will be negative? If m is negative, can I say that acceleration is also negative? Yes or no? M is negative, acceleration is what? Negative. Now, by checking this graph, can I say that at t is equals to 0, what is the velocity? v0. At t is equals to t, what is the velocity? 0. So here, can I say that velocity is getting 0? If velocity is getting 0 and slope is negative, then can I say that acceleration is also negative, and this negative acceleration this time is nothing but retardation? Yes or no? Okay, now if acceleration is negative, where is the direction of acceleration? Towards negative side, na? So this is the direction of acceleration. This is the direction of acceleration. So I want to know that if acceleration is in this direction, where is the direction of velocity? And velocity is decreasing. Finally, it becomes 0. Yes or no? At t is equals to t, whatever the time is, it is coming on the origin now. Yes or no? That means, can I say that body is going in this direction? So this is the direction of motion, and body is going in this direction. While body is going in this direction, velocity is increasing or decreasing? Decreasing. I got my point. So can I say that acceleration is negative and it is retardation? Where is the direction of velocity? Direction of velocity is towards positive side. So velocity is decreasing. Okay, then where is the velocity direction? Velocity is negative, positive? Positive. Velocity is what? Positive. First thing, velocity is decreasing. Second thing, velocity is positive and acceleration is negative, and that's the reason we got what? Acceleration is here as retardation. I got my point. Anything else we can comment over here? 90, negative, slope. Okay, right on. Okay, the next is graph number 4. This is your velocity, this is your negative velocity, and this is your time. Okay, someone please comment on this. Where the body is going, first thing? Negative side, positive side? How? By checking the slope. Okay, let me check the slope. This is your theta 1. This is your theta 2. This is your theta 3. So according to you, a body is moving towards negative side. Okay, someone else? Velocity decreasing. Okay. Anyone else? Okay. Shall I? Now, theta 1, theta 2, theta 3. All are equal. First thing we will write that. So theta 1 is equals to theta 2 is equals to theta 3. That means, can I say that tan theta 1 is equals to tan theta 2, which is also equals to tan theta 3. First thing. Then the next thing is checking the angle. Theta is greater than 90, less than 90? Yes, greater than 90. So theta is greater than 90, definitely slope will be negative. Okay, what this slope is providing you? Acceleration or velocity? Acceleration. Yes or no? If slope is negative, can I say that acceleration is also negative? Acceleration is also negative. In the last example, what we found is initial velocity is v0 and final velocity is 0. That's the reason directly I said that this negative acceleration is retardation in the last one. That is your third. Now this is the fourth, and again we got acceleration is equals to negative. Is that accelerating or retarding? First thing, tell me, velocity is increasing or decreasing? Increasing, na beta. At t is equals to 0, what is velocity? 0. At t is equals to, let's say this is 1, velocity is having some value. At t is equals to 2 seconds, let's say velocity having some more value. So velocity is increasing or decreasing? Increasing, but where? In negative direction. I got my point, what I am trying to say. Here the velocity is increasing, but it is increasing in negative direction, and acceleration is also in negative direction. Can I say retarding? No, accelerating. So this A is negative, yes, but this one is accelerating. Okay, now where is the direction of V? Toward the negative side. If object is going toward the negative side, acceleration is also towards the negative side. Let me write that. So velocity is negative, what we got. Okay, then that means acceleration is negative, velocity is negative. Let's see over here. So object is from here, maybe from 0, it is going toward the negative x-axis. So this is the direction of motion. Velocity is in this direction. Acceleration is also in this direction. Both are in the same direction. That means, can I say velocity is increasing? Yes. So here I can write that velocity is increasing. Velocity is negative. Yes, it is negative. Acceleration is negative. Yes, it is negative. Both are going in the negative x-axis and velocity is increasing. Anything else? Retardation? No, never. By seeing the negative acceleration, you cannot say always retardation. Okay? Right on. Okay, shall I? Fifth one. This is your velocity, this is your time, origin. Now, everyone close the book and listen to me. Again, Same diagram what we have learnt in what xt-graph also. Yes or no? Okay, now listen to me. Before commenting anything, we have to select what? Few points. Let's say over here is the first point. Let's say over here is the second point. Let's say over here is the third point. Drawing the what? Tangents. So drawing the tangents. Okay. Then can I say that this is your theta 1? Can I say that this is your theta 2? Can I say that this is your theta 3? Angle is increasing or decreasing? Yes, increasing. So can I write like this? Theta 1 is smaller than theta 2 and it is smaller than theta 3. Yes or no? Can I also write that as tan theta 1 is smaller than tan theta 2 is smaller than tan of theta 3? Can I? Then can I say that acceleration at first, let this one be having a1, this one be having a2, and this one is having a3. So a1 is smaller than a2 is smaller than a3. Yes or no? Constant acceleration. Yes, variable acceleration now. Acceleration is increasing. Definitely velocity is also increasing. Got my point? Okay, before commenting the slope, positive, negative, theta. Yes. So if theta is less than what? 90 degree, then m is what? Positive. If m is positive, acceleration is also positive. Acceleration value is increasing or decreasing? Increasing. Then can I say that this acceleration is variable? Okay, acceleration is what? Variable. What about velocity? Definitely velocity is also variable. Why? Because if acceleration, even though it is constant, velocity will be changing. So can I say that if acceleration is positive and acceleration is variable, both are moving in the positive direction, acceleration and slope both are positive, then velocity is also, velocity is positive. If velocity is positive, where it is going? Increasing or decreasing? Increasing. Velocity is increasing. You want to comment something else? Rough diagram. Okay. Consider at t is equals to 0, velocity is what? Initial velocity is 0. After some time, acceleration 1, let it may be 2 meter per square second. At this point, let it may be the velocity is 10 meter per second. Sorry. At this point, v1, we got what? Velocity 10 meter per second. Accelerations are not constant. It is variable. After maybe 1 second, it will not be 4 or it will not be 6. Random values. Let's say acceleration 2, over here we got 10 meter per second. Okay, so we got the, at that time, let's say the velocity is 30 meter per second. Similarly, A3 is let it may be 35 meter per square second. V3 is equals to, let it may be 100 meter per second. So if acceleration is not constant, definitely velocity won't increase with the same rate. It will increase with more value, na? Yes or no? If acceleration is constant, can I say that rate of increase in the velocity will be equal? Yes. Acceleration is constant? No. Variable. Definitely rate will be different. Okay. Right now. Okay. Shall I now? Sixth one. Okay. No. Before starting the sixth one, we need to understand something. Okay. Shall I? Consider a body is traveling in this direction. Straight line. Body is moving towards positive x-axis. Let's say at t is equals to 0, u is also 0. T is equals to what? 0, u is also 0. After 1 second, at t is equals to 1 second, let's say I have an acceleration of 100 meter per square second. Okay. That means what will be the velocity here? We can calculate. Why? Because we have a time period, we have the initial velocity, we have the acceleration, then we can calculate final velocity by using v is equals to u plus of at. Can I? Okay. So v is equals to initial velocity is 0, we don't know, plus of acceleration is 100, time is 1 second. So can I say that velocity after 1 second is 100 meter per second? Yes or no? So what is the velocity at this point? 100 meter per second. Okay. After one more second, consider at this point, at t is equals to 2 seconds, I found that acceleration 2 is nothing but 30 meter per square second. Okay. What is the acceleration at this point? I found 30. Time? 2 or 1? Okay, from year to year variable acceleration na beta. So just consider over here. Initial velocity is 100. Time is 1 second between these two. Acceleration is 30. Okay, can we find the time, final velocity, that is v2? Let's say this is your v1. So v1 at this point is 100 meter per second. Let's say this is your v2, and consider now v1 is your initial velocity, v2 is your final velocity. So can I say v2 is nothing but v1 plus of at? Can I? At this point, what is the acceleration? This is 2. So v2 is nothing but v1 is how much? 100 plus of what is the acceleration? Can I say 30? Time 1 second. That is 1. That means can I say v2 is what? 130 meter per second. Did you observe something? Nothing? Okay. One more. Let's say t3 is equals to 3 seconds, and at this point acceleration we got 10 meter per square second. Then can I say that at this point velocity is 130. Let us find this one now. So let's say this is your v3 velocity. Okay. Now, so v3 is nothing but v2 plus of a3 t again. So v3 is equals to what is the velocity at this point? v2 130 plus of 10. So v3 is equals to how much? 140 meter per second. So what is the velocity at this point? v3 is equals to 140 meter per second. Now let me tell you. What is the initial acceleration at this point? 100. What is the acceleration at this point? 30. What is the acceleration at this point? 10. Can I say acceleration from A to V3, sorry, 0 to B, let's say B. So A here and let's say B. Can I say that from A to B, velocity is increasing? Initial velocity 100, 30, 140. Yes or no? It increased. But what happened is acceleration decreased. So can I say that decreasing acceleration can be positive? Can I? One more time. What is happening from A to B? Acceleration is decreasing. Yes or no? Velocity is increasing. Both are moving in same direction. Both acceleration and velocity are positive. That means velocity is positive and acceleration is also positive. But what is happening? Velocity is increasing and acceleration is decreasing. Can I say that? Yes or no? Okay. Continuing this, let's say at T4. At T4, that is 4 seconds. If I substitute the value in reverse order, that means negative acceleration. If I substitute negative acceleration, then can I say that if I say this is the maximum velocity, then at T4, if acceleration is minus 10, I will be getting value of V4 130. Nayara, I am saying that now at T4, acceleration is minus 10 meter per square second. What is the acceleration? Okay. What is the velocity at this point? 140. So initial velocity, let's say minus final velocity. So V4, this is the V4 velocity at this point. V4 is equals to V3 minus of acceleration is minus 10, na? Are yes or no? What is the value of V3? That is 140. So V4 is nothing but, can I write 130 meter per second? Yes? Further ahead. So at t is equals to 5 seconds, I am saying acceleration is nothing but what is the reverse order minus of 30 meter per square second is the acceleration. Then I am saying that now velocity at v5 is equal to how much? 100 हो जाएगा, 100 meter per second. I got my point. If I some more decrease the acceleration, it will be finally becoming what? Zero velocity. Why? Because initial velocity is what? 0. Final velocity will also becomes what? 0. In how many seconds? 3 seconds. So can I say this is the first second, this will be the second second, third second, velocity becomes completely 0. Now what I am trying to say is, as I started from A and going towards B, acceleration is decreasing. Acceleration is decreasing, but it is positive even though velocity is increasing. I got my point. Okay. From B to, let's say, C, B to C, what I found is if I increase the value of negative acceleration, if I increase the value of what? Negative acceleration, velocity is decreasing. See here, 140, then 100, then definitely it will be 0. Got my point? So, can I say that just by saying positive acceleration, velocity always increases? No. Just by saying negative acceleration, velocity always decreases? No. I got my point. So, what we need to find, if acceleration is opposite to the direction of velocity, then and then only we call retardation. Retardation is nothing but not negative acceleration, decrease in velocity. That's the reason I told you at the earlier. Got my point? So, negative acceleration doesn't mean that it is retardation. Decrease in velocity is retardation. Got my point? Okay. So, acceleration is decreasing, but velocity is increasing. Acceleration is increasing, but velocity is decreasing. This is possible. I got my point? This is all about 6 months. If you want to note this, you can note down. Okay. Listen to me, everyone. Same graph like yesterday's. This is your T, this is your V origin. Now listen to me. First need, yes, selecting the points and putting the tangents. Point number 1, point number 2, point number 3, point number 4 and point number 5, drawing the tangents. Okay, the next, this is your theta 1, this is your theta 2, over here theta 3 is equals to 0, this is your theta 4, and then this is your theta 5. Theta 4 looks bigger than theta 5, but just now we have found that we need to consider only what? The magnitude. Yes or no? Okay, from A to B, let's say this is your A, this is point B, and this is point your C. Now, what is the initial velocity? 0. Final velocity at this point? 0. Okay. From A to B, let us discuss between A and B. So, theta 1 is smaller or greater? Theta 1 is greater than theta 2. If theta 1 is greater than theta 2, acceleration is decreasing or increasing. Then can I write this as theta? Tan theta 1 is greater than tan of theta 2. Let us check the slope. Theta is less than 90. Then can I say m is positive? If m is positive, acceleration is also positive. If acceleration is positive, but by seeing the theta 1 and theta 2, I can say that acceleration is decreasing now. Acceleration is what? Decreasing. If acceleration is decreasing, velocity always decreases. Just now we saw. Now, can I say that if here is the velocity 0, if here is the velocity 0, what will be the velocity here? Maximum velocity. Yes. So at this point, this one is having what? Maximum velocity. So can I say that from point O to V max, that is B, velocity is increasing, and from point B to point C, velocity is decreasing. Can I say that? Okay. The next thing what we need to find, if acceleration is positive, acceleration is decreasing its value as it passes away. But what we found, velocity is also positive. If acceleration here is positive, acceleration is what? Positive. What is velocity? Velocity is also positive. Both are moving in the same direction, opposite direction? Same direction. That means from A to B, acceleration and velocity both are moving in the same direction, but velocity is increasing, acceleration value is decreasing. I got my point. Just we saw in the example now, from A to B, acceleration is decreasing, but velocity is increasing. Okay, anything else we can comment over here? No. At point B, so at point B, velocity is maximum. What is acceleration? Acceleration is 0. Yes, very good. Acceleration is 0. So at point B, it is having maximum velocity but 0 acceleration. Got my point? Okay, the next thing, let's say from B to C. Okay, now B to C, theta greater than 90, less than 90. Theta is greater than 90. So B to C, theta is greater than 90. Definitely slope will be negative. If slope is negative, then can I say that acceleration is also negative? Are yes or no? But we know that theta 4 is smaller than theta 5. By seeing theta 4 is smaller than theta 5, I can say that acceleration value is increasing. So acceleration is what? Negative, and it is increasing. Okay, acceleration is negative, but acceleration is what? Increasing. If acceleration is increasing, but finally what we found, velocity at this point is 0. That means can I say that velocity is decreasing? Velocity is decreasing. But it is positive, negative? Positive. Very good, very good. आ गया रे तुम लोगों को समझ में फिर. Velocity is positive. Even velocity is positive, but it is decreasing. Acceleration is increasing. Acceleration is negative. All the points we have. At point B, velocity is maximum. Acceleration is 0. Velocity is also positive. Acceleration is positive, but it is increasing. Velocity is also increasing. लिख लो यहाँ पे. Write one more point. Velocity is increasing here. Okay, velocity is increasing, velocity is decreasing, velocity is positive, velocity is positive, acceleration is positive, acceleration is here negative, over there acceleration is decreasing, acceleration is increasing. At point B, you have everything. Okay, if someone asks you, what will happen if the body continues like this? Okay, your question. If body is continuing in this direction, can I say that after reducing the value, that is acceleration is here increasing. Now, velocity becomes 0. After velocity becomes 0, we all know that if a body is moving in this direction, at any point velocity becomes 0, definitely that body will be returning back its to same path, na? But in opposite direction. Yes or no? So now velocity is also negative and acceleration is also negative. If you want to write, you can write. So beyond C, velocity and acceleration both are in same direction. That is what? Negative direction. And velocity is increasing. Definitely acceleration value also increasing. Okay, why? Because After 0, velocity is also increasing, sorry, acceleration is increasing, but velocity is decreasing. But then after it becomes to rest, then again velocity increases, acceleration is still increasing. Got my point? So that is beyond C. If you want to write, you can write. Okay, shall I now? Now this is your graph. This is your time, this is your positive velocity, this is your negative velocity, minus t here na? Yes or no? बेशर्मो खुद के मर जाओ. Time can't be in negative. Now listen to me. Okay, shall I? Comment on this. Before commenting anything, we need to draw the slopes. Okay, so selecting one point and drawing the slope, and selecting one more point, drawing the tangent and the slope. At this point 0, and let's say at this point here, and drawing again over here and here. So can I say this is your theta 1, theta 2, theta 3, theta 4, theta 5. Okay, now listen to me. Theta 1, theta 2, greater than 90, less than 90? Yes, greater than 90. So theta 1 is greater or less than 90? Yes, theta 1 is greater than theta 2, and that means, can I say that acceleration at 1 is smaller than acceleration at 2? That means acceleration is what? Decreasing, increasing? Decreasing. Very good. Acceleration is decreasing. If acceleration is decreasing, it is positive, negative? Negative, definitely. Why? Because theta is what? Greater than 90. Slope is your negative. That means your acceleration is also negative. Okay. Comment on velocity. Increasing, decreasing? Yes, very good. It is increasing. Initially, the velocity is 0. At this point, velocity becomes maximum. But in which direction? Negative direction. Very good, very good. So velocity is increasing and having a value negative. Velocity is increasing and negative. At point B, let's say this is your point B, this is your point A, this is your point C. That means this story is all about A to B. Then at point B, velocity at B, maximum 0, maximum. So velocity at B is nothing but maximum value. I got my point. I written in last diagram at VB at 0. Are you sure? Check once. If I return velocity at VB is equals to 0, cut that and put maximum. Why? Because over here velocity becomes maximum, over here maximum, over here 0, and over here 0. Okay, maybe while writing by mistake. If I return accepting now. Okay, so at B, VB is maximum and acceleration at this point is 0. Return correct? Glasses change kar le beta. Okay, now, so acceleration is 0, and anything else we can comment? Acceleration is decreasing, acceleration is towards negative side, velocity is increasing and it is towards negative side. At B, velocity is maximum, acceleration is 0. No, so let's move to BC and BC. So at BC, can I say that theta 4 is smaller than theta 5? If this is happening and theta is less than 90 degree, then slope is your positive. Can I? Okay, if these things are happening, then can I say that acceleration is positive and acceleration is increasing or decreasing value? Increasing. Very good. So acceleration is increasing. Acceleration is positive and it is increasing. What about velocity? Comment on velocity. From here maximum velocity, here is your 0 velocity. velocity is towards positive, negative, positive, negative, in this direction. Okay, first thing, tell me velocity is increasing or decreasing? Velocity is what? Increasing. If velocity is decreasing, increasing, decreasing आना चाहिए. Velocity is what? Decreasing. Thank you very much. Velocity is decreasing. Finally, it becomes 0 at point C. It is moving towards positive side, negative side, positive side. Okay, anything else we can comment? If you want to write beyond C, you can. Beyond C, both acceleration and velocity are going in the same direction. At point C, velocity becomes 0. Then acceleration and velocity becomes what? Both positive this time. So beyond C, both acceleration and velocity are positive and increasing. Okay, complete this. Velocity is over. Tomorrow we will discuss v-tGraph. Okay.